Welcome back to this tutorial on recursive descent parsing algorithms for a calculator. In today's video, we're going to be implementing variables. So to begin with, how are we going to store variables? Well, a variable is going to be called by the following. We're going to say some kind of variable name equals and a value. So this is how we're going to adapt our grammar. So at the very beginning, we need to decide whether or not we have a variable assignment or just a simple calculation. So we're going to adjust our start symbol to the following. It's either going to be a statement or it's going to be a variable equals to a statement. So we're going to adjust our start statement, our start function, and also we're going to have to adjust the following. In our final, this was originally number, but now we've introduced a temporary production called value, where value is a variable or a number. So very simple and minute changes to our grammar, but however, we're going to change some of the scanner functions and some of our iterator functions. So to begin with, we're going to have to introduce the equal function, the equal token to our scanner. So I'm just going to copy and paste this. So here we have our scanner. We're going to check to see if the next character is the equal sign. If it is, then we're going to pass in equal. Now the next thing we need to do is make a finite automaton for our variable names. And here is just a simple example, finite automaton. We're just simply going to loop on any kind of letter. So we're not going to accept underscores or numbers inside our variable names, so only letters. And in fact, the loop is going to be very similar to this. So we're going to start at the very end. After checking for numbers, we're going to say elif our char is alpha, which is a stock standard library function in Python for checking if the character is a letter or not. If it is, we're going to construct our variable, and we're going to set it equal to an empty string, like we did here in number. And we're simply just going to loop and append characters to the end of the number, or in this case, the variable string. So we're going to say continue is equal to true, and we're going to say while continue. Here we're going to have our inner loop. We're going to say variable is equal to variable plus char. Next, we need to get we're going to peek at the next token to see if we're at the end of the list. So we're going to say myIter.peek is none, reached end of list. Then what we're going to do is we're going to say token is equal to token. We're going to construct our token. We're going to call it ID. So instead of calling it variable, we're going to call it ID for simplicity. And we're going to say tokens.append token. Else, we're going to peek again, except we're going to store it this time. We're going to say if is alpha. We need to check to see if we need to continue the loop or not, or break out. If it is, then we're going to simply consume this statement. We're going to continue. Yes, we do need to store this, because now, once we loop again, character is still going to have the same previous value. Else, now it's not, the next token, the next character is not an alpha. So we need to break out of this loop and continue it at the very top. So we're going to do that by saying, applying this token, token variable, tokens.append token, and we're going to say continue is equal to false. This way we break out of the loop. And so now, another thing we need to consider in our grammar is the fact that a statement can now contain a variable. So we need to go through all of our previous functions and adjust them as such. So now this is our statement is a negation, a number, an LPAR, or an ID. So I'm just going to copy, paste, ID. We need to go through, make sure all of these have it. So for temp, for T3, and for T2, and for factor. And then now we go to final, except this time we're not going to append it, we're just going to insert it here. So if token.token equals ID, now we have to make our ID here. Now how are we going to store our variables? This is a tricky question, and simply I'm going to make a dictionary where the key is going to be the variable name and the value is going to be the actual value of the variable. So I'm going to come down here, I'm going to make our variable dictionary empty. I'm going to go up here to factor, to final. And so what we're going to do is we need to search in final. Let's say for this example derivation, when we reach final, we go to value, we go to variable, and we need to find the value of this variable and insert it inside of this function and return it. So we need to search our variable list, our variable dictionary, and retrieve that value. So what we're going to do is next we're going to consume then we're going to say we need to search our dictionary. So we're going to say if token dot value is in the variables, we're going to say variable present in dictionary. If it's not, that means we've called upon a variable name that has not been assigned yet. So this is going to be an error. We're going to print out error unexpected variable. And we're just going to print out the token name. And we're going to return none. So we found it, and now what we need to do is get the value from that token in the variables. So we're going to say token, we're going to get the value by using the token name as an index, or the key. And we're going to store that inside the token value. So we're simply going to replace the token value, which should hold the key, to our index inside the variable dictionary, and then we're just going to change the token to none. So let's say in this example, we're given the ID X. So X has a token of ID, and let's just say in this example it has a value of 5. What we're going to do is we're going to search the variable dictionary. Is it present? Yes, it is. Next, what we're going to do is we're going to retrieve the value 5 by going through the variables at the token value index, where the token value is X. We're going to store that value 5 back into token value. And then we're going to change the token to a number. This way, when we return it, we can use it in our following computations. So we're going to return this token. And so now we've adjusted final to accommodate variables and numbers. We haven't actually forgot to implement value. So we're going to have value of my iter, or in fact we don't even probably need value. We can probably get rid of value. So instead of making just another temporary, we can just make another or statement, which is exactly what we did here below. So now the last thing we need to do is how would you assign variables in our grammar? Well, here with the start statement, a start expression, it's either a statement or it's a variable equals statement. Now the problem with this is a statement can also be a variable. So now we have collision. So we need to actually have another look at the equals. So now we're looking ahead again. This would probably be an LL2. Now we need two lookup aheads to predict. So now we're going to adjust our grammar. I'm going to grab this here below, go down to start, and adjust it as the following. So we need to say, we need to actually check to see if the first token is actually an ID. So before we even call statement, we're going to say token is equal to myiter.next, dot peak. And then the next thing we're going to do is we're going to check to see if that token, if token.token is equal to ID. If it is, then we're going to get the name of that variable. And then we need to peek again to see, is the next token after the ID a equal statement? If it isn't, then we need to backtrack and just proceed as normal. So what we're going to do is we're going to say token is equal to myiter.peak, and we're going to say is equal. We're going to say if token.token is equal. Then we actually have an assign statement. If we don't, we need to find a way to go back. And we're going to make a new function in our iterator called back that just decrements the current index value. So now let's, before continuing on, let's actually implement this back value in our iterator. So we're going to go up here, we're going to define a new function called back, and we're basically going to say if self.currentIndex is equal to 0, we're just simply going to return. This is going to happen just in case if somebody was to call back on the first index, we're not going to decrement to -1. That way when the next time we call peak or next, we're going to get a raise exception for index out of bounds. So we're going to say else, we're going to say self.currentIndex -1. And here we can actually make a user-defined exception. However, in this example, I'm going to skip over that and I'm just going to return none. So let's go back down here to our statement, our start function. And now, so once we actually have an equal statement, we know it's an assigned value. So we need to consume this value. So we're going to consume it, and then we need to get the value from this statement here. And it's going to be basically the same as this. We need to check to see, is it none? And also we need to check to see if we reach the end of the list. If we've done all of these things, we're going to make a new variable, and we're going to make the variable key the name of the variable, and its value is simply going to be the value of the statement. And then we're simply going to add this to our variables using the update function. So here that should be working. Let us now run this calculator. We can say x is equal to 5. So token is not callable. Oh, let's see. So unfortunately I'm running out of time right now, and I'm going to stop here and I'll finish up this episode in the next video. So stay tuned.